In this video, we're going to take a look at kind of the experimental side of electrochemistry, or really, again, redox reactions. We'll typically do something called a galvanic cell, which will include two separate compartments, one for oxidation to happen, one for reduction to happen, and some way of measuring the electricity passing between them. As electrons are going from the oxidized species to the reduced species, from the reducing agent to the oxidizing agent, they're going to be measured as an electric current, right? Current in physics is electrons moving through a wire, although it's the opposite direction in physics because they're crazy. But if we take a look at a reaction, let's look at what a galvanic cell might look like. We've got a couple options, typically for chemistry setup. We have two major options. We have two beakers that are filled with solutions. For this reaction, the silver nitrate and the copper, both of the solutions are made of the corresponding nitrates. They're the aqueous components. So we're going to have one filled with silver nitrate and the other filled with the copper 2 nitrate. So really those are copper 2 plus ions, and the nitrate ions are there to just balance things out. So let's just get rid of them. We have the copper 2 plus and the silver plus. Those are in our solution. We're then going to have pieces of metal that are going to function as our electrodes. So this could be a strip of silver. And that's going to be part of the half cell, just like with the half reactions, where your silver process is taking place. The silver being reduced will take place on that side. And we're going to have, on the other side, a piece of copper metal. So in both cases, you're going to have your metal and your ion for both. And now we're going to have a wire connecting the two along with some device that's able to measure the current. It could be an ammeter or it could be a voltmeter, some way of measuring the electric current passing through. And then finally, in order to kind of keep things balanced electrostatically, we also will have what's called a salt bridge. And I'm going to do the salt bridge in another color. Salt bridges are usually made of potassium, or there's some material that's soaked with potassium nitrate. And so as positive ions get used up, as in things are being reduced, that solution is missing positive ions. So from our salt bridge, a positive ion, in this case potassium, will migrate into the solution. And in the side that is becoming more positive, we need to balance that out with counter ions, and the nitrates will move in to the other side. Potassium and nitrate are both inert ions, so they're just there to make things electrostatically happy, meaning we don't want excess positives or excess negatives. We know how unstable those are. So let's take a look at what's actually happening here. It looks like in this reaction we have silver being reduced and copper being oxidized. So we have a reduction half cell and an oxidation half cell. And we should see that these half reactions that are happening here are the copper losing its electrons and the silver receiving them. And so we're going to see here that the electrons are going to move in this particular diagram from the copper side into the silver side. Since the copper reaction is the one that's producing the electrons, that's the one that's going to be sending the electrons away. So those electrons are going to be happening. And as those electrons go away, that's where we start losing those negative charges, because electrons, which are negative, are leaving. They're going through the wire, creating electricity. They're leaving, and so we're going to end up having nitrates come into the solution from our salt bridge to balance out that lack of negative. So as we form copper 2+, we're making things more positive. Salt bridge balances that out by adding nitrates into our solution. And of course, the electrons are going to come along here. They're going to come through the wire, through the electrode, and they're going to start reducing silver ions. So we're going to have silver ions start incorporating themselves onto the silver metal there. We don't necessarily need silver metal. Say we wanted to plate something with silver. So if you want to chrome plate your hubcaps, for example, you would use chromium and reduce the chromium. And we're going to see that as this happens, you're going to form a layer of silver on your metal. Typically, you do it with the same metal, but if you're interested in electroplating, which is something we'll look at next week, you can do it this way, using these galvanic cells. Or you can use electrolyte cells as well. But the point is, we're having the electrons come over. Silver is being now turned into silver metal. That's going to go and adhere to the that silver metal electrode. As those silver ions are leaving solution, we are going to have potassium ions come on in to balance things out. And as a result, we're going to end up filling our solution with potassium ions to balance out that lack of positive now. Note that the electrons are moving from the oxidation side to the reduction side. We have names for these. We're going to see that we're going to call the oxidation side the anode. And we're going to call the reduction side the cathode. And generally speaking, we sometimes indicate the signs of these. So the anode is your negative side of your cell. It's where the oxidation is taking place. And if you want to think about electrons, electrons are repelled from negative things, and they're attracted to positive things. And so electrons always move from anode to cathode in a galvanic cell. Let's write that out in purple. Electrons which are negative move from anode to cathode. If you want to think about where these names come from, we have quite a few mnemonics here. First off, here's the one that I learned in chemistry many years ago. An ox, that is not an O, red cat. If you like animals, that's a way to remember. Anode for oxidation, reduction, cathode. You can also do the fact that both of these start with vowels, and both of these start with consonants. So that may help you. If you are truly a chemistry nerd, you can think of the anode as the part that gets the anion from your salt bridge. How obscure. But if that helps you remember, that's great. So the anode is where your anion goes to. The cathode is where your cation goes to in your salt bridge. So your nitrates will migrate to the anode. Your cations will migrate to the cathode. So you can think of it that way as well. A lot of ways to remember this. And so that's what this looks like. So we'll have some fun with simulations on this. And we can, if we were in person, we would do them in real life as well. But we can't. So, all right. That's how a cell looks. And so in our next video, we'll actually talk about what's the point of all this and how we can relate it to our dear friend, equilibrium. You thought we were done with equilibrium, huh? Nope. Wait a couple of videos and we'll see.